So, product rule is a rule that we can use to find the derivative of two things that are multiplied together. So, if you're finding the derivative of f of x times g of x, what you cannot do is just find the derivative of f and the derivative of g. That does not work. Coach Wood, when you let him in. I emailed Calc last week and they said they were renewing, but mine has expired too, and these guys are upset because I was going to give them a quiz on Delta Math, and now I can't give quizzes on Delta Math because
they get 2 tries.
not on the quizzes. But they were upset because I was going to give them this quiz on Delta Math, and now they don't even get to take the quiz at all because I didn't have time to make another quiz. Huh?
It's expired, but I think it's actually working.
Mine won't let me do the quizzes because I checked yesterday, but it will still let me do assignments, which I guess is what the free version does. But they said they were reordering that, but mine ain't working yet either. It's okay. It's okay.
I remember you telling us about it.
I didn't tell you about it yesterday because I forgot, and I was going to send you guys a reminder. I sent you one saying we would not have a quiz in case anybody had checked Canvas and saw that it was there. But I was going to send you a reminder telling you about the quiz, and then I realized that I couldn't give you that quiz because Delta Math was down, and I did not have time to make anything new, so I just got rid of that one. So sorry, guys. I know you're disappointed. You can thank the tech department for that one. So send your grievances their way. All right. So f of x times g of x. You cannot just take the derivative of the first one and the derivative of the last one. That is what students do wrong most of the time. They don't recognize when they've got to use this. So if you're taking the derivative of f of x times g of x, the product rule tells us we do f of x times g prime of x plus g of x times f prime of x. So it's original f times derivative of g plus original g times derivative of f. Okay? Or would it matter if we did them in the opposite order? It would not, because you got a plus sign in between them, so if you switch them, it's fine too. Right, if it had, and tomorrow in quotient rule, we're going to have a minus. So we can't switch tomorrow, but today, if you did g first, it wouldn't matter. So if I'm asked to find the derivative of x squared times cosine x, okay, derivative of x squared times cosine x here, I have got one expression right here, okay, and a second one right here, and those two things are multiplied together. All right. Both of those expressions have x's. If this was 2 times cosine x, then I don't have to use the product rule. I could, but I don't have to because 2 is just a scalar multiple, right? So we did those yesterday. But if I have something out here that has an x with it, I'm going to have to use the product rule. So here's what it will look like. Here's our f. Here is our g. So for our derivative here, I would do f, original f, so that's x squared, times derivative of g. What is the derivative of cosine x? Negative sine x. Let's make sure we put some parentheses so that doesn't look like we're subtracting. Then we got a plus sign in the middle. Then we need to do g of x, original g of x, so that's cosine x, times derivative of f. What is our derivative of f? 2x, right here. And sometimes these are going to have a lot of simplification that can be done, and the ones with sines and cosines, usually not. So you would probably see this cleaned up a little bit, where we have like negative x squared times sine x plus 2x cosine x. But there's not really anything else you can do with that. You can't combine anything, so you would just leave it there. Okay, so just pointing out where everything came from again. This was our f. This part right here was our f prime. This part right here was our g prime. This part right here was our g. Okay, everybody good there? Okay. All right, so let's look at this applied in some different ways. So number 2, I'm going to do 2 ways for you. Okay, because number 2, there's 2 options, and honestly, the way you already know how to do might be easier. So here I've got 2 things, and they are multiplied together. So I could use product rule for this. So I could let this part right here be my f, and this part right here be my g. So I would do f 3x minus 2x squared times the derivative of g. What would the derivative of g be? Just 4. Plus g, so 5 plus 4x, times the derivative of f, so that'd be 3 minus 4x. There. So I'm going to label just so everybody's got, this was our f, this was the f prime, this was our g prime, this is our g, and then this one you would want to simplify, so you could distribute that 4, and you would get 12x minus 8x squared. Over here you've got to distribute, so you have plus 15 minus 20x plus 12x minus 16x squared. And then you could combine your like terms. So you've got a negative 8x squared and a negative 16x squared. That's going to give you negative 24x squared. We got a 12x, negative 20x, and another 12x. That'll give me plus 4x. And then we'll have that plus 15 on the end. So that would be your derivative there. Now, this particular problem does not necessarily have to be done with product rule. How could you avoid using product rule on this? What do you mean by do it together? Yes. So we could instead on this one, so I'm going to run through it this way, because when it comes down to it, this actually might be easier to do the other way for this. There's going to be some we have to use product rule for, and some we've got some options on. So if I look at this same problem again, I could have just multiplied them together in the beginning. So before I take the derivative, I could have done 15x plus 12x squared minus 10x squared minus 8x to the third, and if I combine my like terms, I would have negative 8x to the third plus 2x squared plus 15x. So you can multiply it together first. Then you just use power rule, which gives you negative 24x squared plus 4x plus 15, which is what you had over here as well. So you don't necessarily have to use product rule on that one, but if if you're going to use power rule, you've got to multiply it together first. Okay. We're going to see some where we might have 3x minus 2x squared, and then we'll have like a square on the outside. We're not going to see those for a little while because it requires you to learn one more rule first. Those you pretty much have to use. You could expand, but it'd be a nightmare. So we will see some that look like this that we have to use it, but for these you could really go either way. Okay, here's an example. We've got f of x equals 3x sine x minus 2 sine x. So really I've got two different things I'm taking the derivative of, the 3x sine x and the minus 2 sine x. Which part do I have to use the product rule for? The 3x sine x. Do I have to use the product rule for the second one? I do not, because this 2 does not have an x with it. It's just a scalar multiple. This is like you were doing last night. So, but up here, I do have a 3x and a sine x, so I have to use the product rule for that. So if you have an x in your expression that's being multiplied, you're going to have to use product rule. So f prime of x is going to be, we'll have 3x times the derivative of sine x, which is cosine x, plus sine x times the derivative of 3x, which is just 3. It's okay with you guys to put my 3 right there instead of second. That way it looks prettier. Now, this stuff right here is only the derivative of that first part. I also need to take the derivative of the negative 2 sine x. What is the derivative of sine x? Cosine x. So that's just going to be minus 2 cosine x. There's really not even anything to clean up there. That's pretty much just your answer. So 3x cosine x plus 3 sine x minus 2 cosine x. Okay here? This is your slope of your line tangent to the graph there, but it is not like your equation of your tangent line or anything, like a y equals mx plus b sort of thing. For them to ask that, they'd have to give you a point where you're plugging that in. Okay. All right, so we've got this other weird problem where we don't know all the pieces. We've got f of 3 equals 4, f prime of 3 equals negative 2, g of x equals 3x squared times f of x. We are supposed to find g prime of 3. Okay, so we got lots of pieces here, but let's see what it's trying to get us to find. We've got to find g prime of 3. Before we can find g prime of 3, we got to find g prime of x, and then we'll plug in 3 when we get that answer. So our g of x is 3x squared times f of x. This must be a product rule because you got two pieces that have x's in them that are multiplied together. So I'm not going to call these f and g like I did on the last ones, mostly because the letters f and g are already in the problem. So let's call this one like K, and we'll call this one J, right? Or something like that. So when we take this derivative, we have to do our K, which is 3x squared, times the derivative of J. What is the derivative of f of x? F prime x. We don't know what the function is, but we can call it f prime of x, right? Plus, now we got to do j, which is f of x, just plain f of x, times the derivative of k. Troy, what's the derivative of our k part? Our k part's our 3x squared. What would the derivative of that be? 6x. Okay, so to make sure we know where everything's coming from there, this part was just k. I just wrote it. This part over here was my k prime. This part right here was my j. I guess I could have called that one f since it is f. And this was my, sorry, that was my j prime. That was my j right there. So, I'm going to clean that up just a little bit. We usually like to put variables first. So it's 3x squared times f prime of x plus, let's put the 6x out front, 6x times f of x. What were they asking us for this problem? G prime of 3, which means I need to plug 3 into this equation. And when we're finding G prime of 3, just like with all notation for functions, we just replace all of our x's with 3's, right? All of our x's have to become 3's. So this is going to be 3 times 3 squared times f prime of 3 plus 6 times 3 times f of 3. Now, f, I don't know what the function is, but do I know f prime of 3? They gave it to me up here. F prime of 3 is negative 2, right? And I've got this f of 3 over here, right here. I do not know what the function is, so I can't plug it into 3, but do I know f of 3? Yes, it is 4, right? So those there I can replace with numbers. Why is it going crazy now? So I've got G prime of 3 equals 3. Let's go ahead and raise that to the second power. That's 9. And then f prime of 3 is negative 2. Plus 6 times 3 is 18. F of 3 is 4. Okay, so we got 27 times negative 2 plus, 18 times 4 is going to be 40 and 32, 72. And then if we double 27, it's going to be 50, negative 54. Yeah. And then if we subtract those two, it's going to be 18. Is that right? No, that's not right. Or is it? It's 18. Okay, so that would be our, I guess I could carry this down if I wanted. The G prime of 3, you're really okay if you put a string of equal signs. What I have seen a few of you doing is just like writing your work down without any equal signs. I would at least put the equal sign. If you don't want to write the G prime of 3 every time, that's okay. But put the string of equal signs showing those are equal. Okay, so you don't necessarily have to know the function to be able to use product rule for this. Okay, here. Alright, we've got one more. Alright, so we've got this graph. They've given us f of x and g of x. They're telling us that h of x is 3f of x times g of x. And they want us to find h prime of negative 1. Hello? Yes. That he told me the purchase order has been sent in, but now it wouldn't hurt to send something else. All right, thanks. All right, thanks. Bye. All right. Okay. So let's not even look at the graph at the beginning, okay? We want to take the derivative of 3f of x, g of x. This 3 out front, you have an option of what you want to do with it. You can keep it all the way out front, or you can group it with your f of x. It does not matter which one you do there. So I kind of prefer to keep it like all the way out front, but it really does not matter. So if I'm finding h prime of x, I can just kind of keep the 3 out front and then deal with my derivative over here. Or if you wanted, you could do like the 3f of x together and then g of x is your other function. So for this, you're basically just using product rule itself, right? You're doing f of x times the derivative of g of x plus g of x times the derivative of f of x. Okay, so that's it. And this is asking us for h prime of 1, which means all of the x's need to be replaced with 1's. So I've got f of 1 times g prime of 1 plus g of 1 times f prime of 1. Never mind. Make all those negative 1s. Negative, 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 negative. There. How do I find f of negative 1? I look at the graph. So I'm looking where f equals negative 1. Here's my point on the graph. What do I report for that, for f of 1? It'll be 3. You're looking at the y coordinate right there. So the negative 1, 3 is on the graph right here. So f of 1 is 3. If you want, it might even be helpful to do, like over here, f, let's do this, f of negative 1 equals 3. I also have to find f prime of negative 1. What is that?
0.
It's not 0. What does f prime give us? Is the slope of the tangent line, or in this particular case, the line itself, since it is a line. Negative 3. Slope of this is negative 3, because if you go down 1, 2, 3, and to the right 1, you'll be on the graph. All right, let's go ahead and do the others while we're looking at the graph. So g of negative 1, we're also going to need. So g of negative 1, what would I get for that? Negative 6. Okay. What do I get for g prime of negative 1?
Is it 2?
Yep. Up 2 to the right 1. I know the graph's a little small for you guys to see, but up 2 to the right 1. So that has a slope of 2. So when you're looking for the derivative, you're looking for the slope of that line. They could pretty much only give this to you if they either had drawn in the tangent lines for you or just gave you straight lines to begin with, because if it's a curve, they're not going to ask you to estimate. So f of negative 1 was 3, g prime of negative 1 is 2, g of negative 1 is negative 6, and f prime of negative 1 is negative 3. So we've got 3 times 6 plus 18, which is 3 times 24, which is 72. Yeah. AP, it seems like lately has been loving giving problems like this, like ones where you don't actually have the equations. You don't have like the equations that you got to work out, but you got to like do it in theory here. Well, this tests several things at one time because it makes sure you know product rule, but it also makes sure that you know how to like find f of -1 and how to find f prime of -1 and what that means. So it does test several things at one time for that. So here's your assignment. Let me look over it real quick, make sure that's everything that I want right there. 154. Look at us finishing in time for you guys to do most of your work in class. We need to do this more often. All right, let's see. 1 through 6. No problem. And then 13. 17. 19, no problem. 16. 17.
I'm not going to do it. It's just like,
I'm gonna add a couple on here. 87A. Only do A. We don't know how to do B yet. And 88A. And 87 and 88 are similar to that last question that we just did. No, they're all of those are, they don't have parts. They're just single questions. Yeah, they're single parts. They're not too bad. On problems like number 1 and 2, you have the option, you can multiply them together and just use power rule. You don't necessarily have to use product rule on those, but then when you get down past that, you're going to have some that you have to use the power rule. Product rule. I get those two mixed up.